Okay, so very good morning. So in the last class, I think I have explained about the voltage divider bias. Okay, it is what actually the voltage divider bias and how actually it is what the DC analysis for the load line and the operating point is to be analyzed. So has been studied in the previous class. So, and in this class, I am going to explain about the features of the few amplifiers. Okay, it is an amplifier features. So, in this class, we are going to study the features of the direct coupled amplifier, is features of the RC coupling amplifiers, and the transformer coupling amplifiers, radio frequency amplifier, okay, radio frequency amplifiers, and also it is what the definition of the voltage amplifier and the power amplifier. Okay, all this. Okay, so that we are going to study in this class here. So if you take the features of the direct coupling amplifier, so if what is a direct coupling, so that you can see it is to be understood with the name only here. So if you take the two stages of the amplifier, so in this case, it is one stage is to be connected to the other stage. It is with the direct coupling here. It is with the direct wire, or it is going to make use of a single resistor as the link in order to connect from the one stage to the other stage. Assuming it is what this BZT is of the one stage, and it is what this BZT2 is the second stage. So the output of the first stage is to be connected as an input to the next stage with a direct single wire, or it can be connected with it is a resistor. Okay, it is itself is called as the direct coupling here. Okay, so it is the output of the one stage is to be connected directly, or it is via a component such as the register. Only the register is to be used here. It is to put the input of the next stage. So this is itself is called as the direct coupling here. So in case of the it is a direct coupling amplifier. It is usually used to amplify the zero, or it is the low frequency signal. So it is used to amplify. It is mainly of the DC signal. Okay, if the frequency is equal to 0 means it is called as the DC signal. So it is used to amplify the DC signal or of the low frequency signal here. And in this case, it is the output changes with the age or time, or the change in the supply voltage. So according to the time, or according to the usage, and according to the change in the input, it is at the first stage, it is going to change its output here. And if you take the transistor parameters, like it is VBE and the beta is going to changes with the temperature, and it is going to cause a change in the collector current and the voltage, and it is therefore the output is going to change. So it has been explained in the second class here. It is what are the parameters it is going to affect the stability here. So it is the ICO, VBE, and the beta. So if you take the direct coupling, in this case, the voltage VPE and the beta is going to get changed with the temperature. And if these two parameters is going to change, according to that, it is going to change the collector current, and it is going to change the output voltage here. And any noise or the stray pickup appearing at the input of the amplifier increases at the output, it is due to the high gain. So if you take the direct coupling amplifier is usually of the what high gain amplifiers. So if any of the minute noise is to be acting as an input, means according to that it is going to change its output, and according to that it is going to increase its at the output, and it is having of the gain, what high gain. Okay, so if you take the direct coupling amplifier, the output of one stage is connected, okay, directly, or it is via a component such as the resistor, and it is mainly used to amplify the zero or of the low frequency signal. And in this case, the output changes with the age or the time here, or it is mainly due to the change in the supply voltage. Okay, according to that it is going to change the output here. And if you take the transistor parameters, it is based on the alteration of the VB and the beta. It is with the temperature, it is going to change the output current, and according to that, output voltage is also going to change here. And any noise appearing at the output of an amplifier increases the output. It is mainly because of the high gain here. All these are the features of the direct coupling amplifier. It is connected, okay, directly with a single wire or with the help of the resistor here. This is with the direct link. This is with the resistor link here. Okay. And if you take the one more, it is RC coupling amplifier. It is a RC indicating it is a resistor and the capacitor coupling. Okay, or it is going to make use of only the capacitor. It is also called as an RC coupling amplifier only. So that you can able to see in this case, if you take this is the first stage, if you take this is the second stage, so the output of the first stage is to be connected with the input of the second stage with the coupling capacitor here. It is called as it is coupling capacitor, and it is itself is called as an RC coupling amplifier here. So a coupling capacitor or the CC is used to connect the output of the one stage to the input of the next stage, and it has a as a it is great frequency. It is what response. So already you know that if you take the capacitor, it will allow to pass only the AC signal and it is going to block the DC. So for that purpose, it is having a great frequency response. So the gain is uniform. It is over the audio frequency range, which is important for the speech, it is music and etc. So it is mainly used, it is to couple the audio amplifiers here, and it employ only it is resistors and the capacitor, which are of the cheap and it is of the low cost here. It is of the low cost. And what the circuit is very compact, it is due to the small size and it is lightweight of the resistors and the capacitor. So it is what the implemented device is also going to be of the less weight here. And impedance matching is poor. It is because the output impedance of the RC coupled amplifier is several hundred ohms, is whereas the input impedance of the speaker is only in terms of the few ohms. It is going to be, it is only one, okay, disadvantage of the RC coupling. The impedance matching is poor. It is because the output impedance is in terms of hundreds of ohms, and it is whereas the input impedance is only in terms of it is ohms here. And it is mainly used as an voltage amplifier. It is used to amplify the voltage of the AC signal. Okay, so I'm going to repeat again. In the if you take the features of the RC coupling, so it is going to make use of the coupling capacitor in order to connect the output of the one stage to the input of the next stage, and it is having a great frequency. It is okay response. So what this gain is uniform. It is over the audio frequency range, which is important for the speech, music, etc. And it is of the low cost, and it is of the small size. It is because it is going to make use of only it is a resistor and the capacitor. And in this case, impedance matching is poor. It is because the RC coupled amplifier is having it is several hundred ohms of the input output impedance, and the input impedance is only in terms of a few ohms, and it is mainly used as an voltage amplifier. Okay, this is about the RC coupling amplifier. And if you take the transformer coupled amplifier, so in the transformer coupled amplifier, instead of the capacitor, it is going to make use of the transformer, so that you can able to see this is the primary coil. It is to be connected to the collector or output of the one stage, and you can able to see this is the secondary coil. It is to be connected to the input of the next stage here. And if the transformer connected as in this way, this is itself is called as it is transformer coupling amplifier. Okay, so in the transformer coupling, okay, the signal current, it is flowing in the collector circuit of the one stage. You can able to see this is the collector terminal. It is collector okay, circuit of the one stage. It is flow in, it is through the primary winding of the transformer. It is which induces a signal voltage into the secondary winding, is connected to the input of the next stage. This is the secondary winding. It is to be connected to the input of the secondary stage, and the arrangement itself is called as it is the transformer coupling here. And in this case, there is no loss of the signal power in the collector or in the this base resistor. Either in the base or in the collector, it's not having any of the power loss here. And it is having an excellent impedance matching. It can be achieved in the transformer coupling. And it is due to the excellent impedance matching. So the transformer coupling is going to provide the very high gain. In case of the RC coupling, the impedance matching was poor there, but in case of the transformer coupling, the impedance matching is excellent here. And it has a it is poor frequency response. In the RC coupling, so it was the greater frequency response. But in this case, what this frequency response is very poor. And what is coupling transformers are bulky and expensive at the audio frequencies. Obviously, if you hold the capacitor and the transformer, so it is what this transformer is assumed to be the bulky here. It is of the more weight if it is compared to the capacitors and the resistor. So for that purpose, it is assumed to be the bulky here. Okay, and it is also of the high cost. And what this frequency distortion is higher, it is low frequency signals, or it is going to be less amplified as compared to the high frequency signals here. So it is mainly applicable for the what high frequency amplifier, because it is less frequency, it is having the frequency distortion. Okay, and what this transformer coupling may introduce a hump in the output. It may able to generate it is light variations in the output with the humps there. Okay, these are all the features of the transformer coupling amplifier. Again, I am going to repeat here. If you take the features of the transformer coupling, so the output of the one stage collector terminal is to be connected to the primary coil of the transformer, and if the secondary coil of the transformer is to be connected at the input of the next stage, and the arrangement is called as the transformer coupling. And in this case, it is what this it is power loss is not available. Okay, and it is having an excellent impedance matching, and it is having the what higher gain, and its frequency response is poor, and it is going to be the bulky and expensive. And what this frequency distortion is higher at the low frequencies, and what this transformer coupling introduces the hump in the output. All these are the features of the transformer coupling. Okay, and the next you take the features of the audio frequency amplifier. Okay, AF amplifier. AF means audio, A indicating the audio. If you take any of the speech, or if you take any of the music, or if you take any of the tone, etc., etc., so which the human can able to okay recognize or identify. Okay, those signals are called as an audio signals here. And what is audio frequency amplifiers of the amplifier? It is which is used to amplify the audio signal which is in the range of the 20 hertz to it is 20 kilohertz. If it is in this range only, so that it can able for the human being to hear. So an audio frequency amplifiers are used to amplify the signals in the range of the human hearing, so that human is capable to able to hear the voice. Okay, it is such a signal is called as an audio signal, and it is approximately in the band of it is 20 hertz to 20 kilohertz. If it is less than the 20 hertz, or if it is above the 20 kilohertz, it is very difficult for the human ear to recognize or to hear. It is some hi-fi audio amplifier extend this range up to around 100 kilohertz. So it is, I said, audio frequency range is equal to 20 kilohertz, and on installing or on okay adding the extension of the hi-fi, so that it can extend its range up to the 100 kilohertz. It is whilst the other amplifiers may it is restrict the limit to this 15 kilohertz, or it is less also. And audio voltage amplifier are used to amplify these low level signals from the microphone, or from the tape, or from the disc pickups, etc. It is what I am speaking now is to be get observed by the microphone here. It is from the microphone it will be converted into the tap, and afterwards it is to be sent to the speaker. So what this is to use to amplify, it is low level signals from the microphones here. It is with the extra circuitry, okay, they also perform the functions. It is such as of the tone corrections, equalization of the signal sign, it is mixing from the different inputs. So on adding an extra circuit for an audio amplifier, it is also used to generate the new tones. It is by mixing, or it is also used to do the modulation with the tone corrections, so that what the unwanted signals or unwanted noise it can be eliminated, and a pure signal so has been taken. It is with adding the extra circuitry. And what this or generally have the high voltage gain and of the medium is to high output, okay, resistance here. And audio power amplifiers are used to receive the amplified input from the series of the voltage amplifier, and then it provide the sufficient power to drive the loudspeaker. It is what I said now, it is what I am speaking now, it is to be get taken by the microphone. It is with the series of the voltage amplifier, and after that what that signal is to be amplified, and it is to be sent to the speaker, so that it can able to identify in terms of the loud or increasing with the amplitude level in the speaker here. So all these are the features of the audio frequency amplifier. Understood? Okay, again I am going to repeat. Audio frequency amplifiers are used to amplify the signals in the range of the human hearing, approximately of the 20 hertz to it is 20 kilohertz. It is some hi-fi audio amplifier extend this range up to 100 kilohertz, or it can also restrict with the it is 15 kilohertz or the less. And audio voltage amplifier are used to amplify it is low level signals either from the microphones or from the tape or from the disc pickups, etc. With the extra circuitry they also perform the functions as of the tone corrections, equalization of the signal levels, and it is mixing from the different inputs. They generally have the high voltage gain and the medium to high output resistance. The output resistance, it may be high or it may be the medium, so but the voltage gain is always high here in the audio frequency. And what this audio power amplifiers are used to receive the amplified input from a series of the input voltage amplifiers, and it can provide the sufficient power it is to drive the loudspeakers here. Okay, all these are about the features of the audio frequency amplifiers. And if you take the features of the radio frequency amplifiers, if you take the features of the radio frequency amplifiers, in this case, what these radio frequency amplifiers are, okay, tuned to amplifiers in which the frequency of the operation is governed by the tuned circuit. So as that of the audio is having the certain band, in the same way what this radio frequency is also, okay, having the certain band, and it is in terms of the kilohertz here, and it is to be get operated with the it is with it is by it is the tuned circuit. Okay, and what this circuit may or it is may not be adjustable, okay, depending on the purpose of the amplifier. So it is once the frequency has been set, it can't be changed in the radio frequency. Okay, so, okay, suppose consider an example. If the frequency has been set for any of the radio station, it is going to be, okay, fixed, and it can't be changed so as the time elapses. In the same way, so it can't be allowed the same frequency it is for the other station. In that way, what this circuit it may or it may not be adjustable, it is depending on the purpose of the amplifier. It is what this bandwidth also depends on the use, and may be relatively this wide band or it may be the narrow band. What this bandwidth is to be depends on the application. Okay, either is it used for the FM or is it used for the AM or etc. Okay, it is based on that one. It is going to be used. Okay, and in this case, what is bandwidth also depends on the use, or it may be relatively either of the wide band or of the narrow band. And what this input resistance is generally okay low, and what as is the gain. That means that what this gain is also low in case of the radio frequency. And in the earlier stages of the receiver is of the low it is noise performance. So it can be extended to the successive stages and also for the modulation and the demodulation. After that only it can able to receive, it can able to okay, remove the entire noise, or else in the earlier stages it is of the what it is of the low noise okay performance. And it is important that what this background it is noise okay, generally produced by an electronic device is kept to be the minimum. It is because the amplifier will be handling the very low amplitude signals from the antenna, which is in terms of the microvolts or the smaller. So it is whatever the circuit you are going to build with, it is for the radio frequency okay receiver. So it should able to generate the very less okay noise. If it can able to generate any of the signal which is in terms of the micro which is in terms of the micro volts, it can be get observed by the antenna. So so it is because the antenna it is having the capacity to observe the very low amplitude signals also, which is in terms of the micro volts or even the smaller. And it is the common to see it is the low noise FET okay transistor used in these stages. In the RF amplifier, it is going to make use of the FET transistors. Okay, all these are the what the features of the RF amplifiers. Okay, so that if you take the features of the RF amplifier, so what this radio frequency amplifiers are, it is tuned amplifiers in which the frequency of the operation is to be governed by the tuned circuit. And what this circuit may or it may not be adjustable, it is depending on the purpose of the amplifier. And what this bandwidth also depends on the use, or it may be relatively wide or the narrow. And what this input resistance is okay, generally the low as is the gain. In the earlier stages of the receiver is of the there is low noise performance here, and it is important that the background the noise is generally produced by an electronic device is kept to be the minimum. It is because the amplifier will be handling the it is very low amplitude signals from an antenna, which is in terms of the microvolts or even the smaller. And it is common to see to the low noise FET transistor used in these RF amplifiers. Okay, this is about the features of the RF. And the next one, if you take the voltage amplifiers, and it is what is power amplifier. What is this okay difference? The amplifiers can be classified as an voltage and power amplifiers. And what this classification of an amplifier as a voltage or power amplifier is made by comparing the characteristics of the input and the output signal. It is depending upon it is measuring of the input is in terms of an voltage or in terms of the power, and the output measurement in terms of the voltage or in terms of the power. It is to be classified into of the main two types. One is an voltage amplifier and another one is the power amplifier. In the what this voltage amplifier is used to amplify in which the output voltage signal is larger than the input signal voltage. So it is going to measure in other words, a voltage amplifier amplifies the voltage of the input signal. In the same way, what you if you take the power amplifier is an amplifier in which the output signal power is greater than the input signal power. In other words, a power amplifier amplifies the power of the input signal. So voltage amplifier is used to amplify the voltage, or this power amplifier is used to amplify the power. Okay, suppose consider an example. All the small signal amplifiers are called as an voltage amplifier. It is used to take the input in terms of the microvolts or in terms of the millivolts, and it is to be get amplified. Voltage, what about the power? It may or it may not vary, but what this large signal amplifier is going to accept the input in terms of the voltages, but it is going to amplify the power, in which the voltage, it may be increased or it may be okay decreased according to the application you are using here. So it is, suppose consider, it is what this first diagram, so that you can observe this is an input, and you can able to see it is an amplifier, and the output is taken at the output of the amplifier here, and this is an input signal, and what this is an output signal. It can be easily observed that the output amplitude is more than the input here. So that input signal amplitude is equal to, it is 200 millivolts of the peak to peak here, and it is what this output received is of the what the 4 volts peak to peak here. It is 200 milli means it is equal to 10 to the power of it is minus 3, so that means that it is equal to 0.2 volts. If you apply the input as of the 0.2 volts, the output will be 4 volts, so the voltage is amplified. Okay, the what this amplification is done in terms of the voltage, so for that purpose it is called as an voltage amplifier. If you consider the one more example, again this is an input and this is an amplifier, it is an output, and in this you can able to see this voltage signal amplitude at the input is more if it is compared at the output here. So in this case, what is input signal is, it is having an input of the 10 volts. It is having of the input of the 10 volts peak to peak, and the output is equal to 5 volts of the peak to peak. So the output voltage has been okay decreased, and after that you concentrate on this okay current. Input current is equal to 100 milliamps and output current is equal to 2 amps. So after multiplication of this one, so if it is to be measured in terms of the power, the input power is equal to 1 watt and the output power is equal to 10 watt here. So that output power has been increased by 10 times, but the voltage has been okay decreased. And if the amplification done in terms of the powers, this is called as the power amplifier. The voltage amplifier is called as the small signal amplifier. And what is power amplifier is called as of, it is a large signal amplifier. Understood? This is about, so if the you can able to see the definition here. Voltage amplifier amplifies the voltage. What is power amplifier? Amplifies the power of the input signal. In the first case, you can able to see the amplifier, so it has been amplified the voltage, millivolts is to be converted into voltage. But in this you can able to see the amplification is done for the power. It is of the 1 watt has been increased to okay 10 watts. This is called as the power amplifier. So in this class we have studied is what here, it is features of the direct coupling. In this case it is going to make use of only, it is a direct link, or it is going to make use of the resistor. And in the RC coupling, it is going to make use of, it is coupling capacitor in order to connect from one stage to other stage. If you take the transformer coupling, it is going to make use of the transformer in order to connect from the one stage to other stage. And audio frequency amplifier is going to amplify the signals in the range of the or human hearings from it is 20 hertz to it is 20 kilohertz. And if you take the RF frequency, this is to amplify it is tuned amplifiers. Yeah, it is with the tuned circuit here. And if you take the voltage amplifier is used to amplify the voltage signal, and what this power amplifier is used to amplify the power signal. Okay, so this is all about the features of it is amplifiers. So what is this possible okay descriptive questions means, so that he may ask you to list the features of the direct coupling amplifier, or he may ask you to list the features of the RC coupling amplifier, or just to list the features of the transformer coupling amplifier, or to list the features of the audio frequency amplifier. Okay, just list the features of the radio frequency amplifier, or he may ask you to explain the voltage amplifiers and this power amplifiers. So all this is about, it is about, it is the features of the amplifiers. And in the next class we are going to study the feedback in the amplifiers. Okay, okay, thank you.